as I announced last Wednesday, today's lesson, today's lecture, is a bit more scientific, in the sense that we have to go through what does it mean that physical cosmology has cosmological models, and why these cosmological models could say something or not, could say anything about the theological notion of creation, and vice versa, if our theological notion of creation has to say anything over on our cosmological model, physical cosmological models. And I have organized my talk in these chapters. First chapter is Scientific Cosmology and Theology of Creation, separation of fields or fruitful interaction. If you remember, in our first lecture, we already discussed a bit about the possibility of maintaining two absolutely separate discourses on natural sciences and on theology. And we judged, in that moment, this solution uncomfortable, because we look for some interaction as far as we maintain that we have only one world, and the world which is the object of natural sciences is also the only world we believe created by God, Creator. Second chapter, Cosmological Models and the debate on the possible role of a God Creator. Third chapter, the notion of creation between philosophy of nature and theology. And fourth and last chapter, conclusions, cosmology, theology, and human wandering on ultimate questions. This last chapter is something more than just a last slide of conclusions. It is a special chapter in which I try to convey, to transmit you what, in my opinion, are the most important things to maintain and to say about this topic. No? This is something more than just a few conclusions. It is a conclusive chapter. Separation of fields or fruitful interaction. Do you know these two guys? Albert Einstein. And we have also Albert Einstein's signature here. Are you able to see Einstein's signature here? Okay. And the other is of Monsignor Georges Lemaitre. This picture was taken at California Institute of Technology in 1933. So the only fact that these two guys are together and are picking each other could suggest that perhaps there is a kind of fruitful interaction. We don't know what they were speaking about, but we can imagine that the topic of their conversation had something to do with the origin of the universe in the theological perspective and in the scientific perspective. Why explore the relationship between scientific cosmology and theology of creation? The idea that we're dealing with two independent and in some way incommensurable fields of study would seem acceptable to many. And I guess that if you ask this question to the majority of Catholic theologians, not a great majority, to a slight majority, 55%, 60%, I imagine that the answer is that, well, yes, it is interesting to know something about physical cosmology, but my view is that they are absolutely two independent fields. Theology and sacred scripture deliver a spiritual message that has no necessary relation to the developing of physical facts. This is one of the reasons they could offer to back their thesis. Another reason offered is that science is based on provisional and fallible results. Theology should not bound itself to a specific scientific worldview. Learn from the past, agiocentric, learn from the past. Do not marry with any cosmological model. Leave it. Because it causes troubles. Okay. Theology and science offer two different and independent readings of the world, of life, of the human being, capable of coexisting together as far as they do not claim to convey the only truthful account of facts. Each of them has their own story. Let them tell their story. It is a story. It's not the history of fact, it's story. However, there are good reasons to take a closer look at this relationship, comparing the views of science and theology. What are the reasons that could back this thesis? Scientific research raises philosophical and sometimes even existential questions, to which Christian theology claims to have the answers. If scientific cosmology better said, if some cosmologists, some personal subject doing science asks, what is the origin of the universe, or why the universe came into being, a theologian could answer, because God, Creator, decided to participate his being ad extra. So this is a theological answer to a question raised in the environment of scientific culture. Not raised, strictly speaking, from scientific method, but raised within the scientific culture. Theology can better understand the content of Scripture and God's plan for creation, also thanks to the results of science. The universe, which is the object of the natural sciences, is also, as we said before, the one and the same world which God has created through His Logos. We search for a unity of knowledge in which what we know by science must not be contradicted by what we know by listening to the Word of God. This is our basic feeling. This is a profound intellectual requirement of our minds. John Paul II is on our side. Let's have a look to this page of Fides et Ratio. We are in the 25th anniversary of the publication of this encyclical. The unity of truth is a fundamental premise of human reasoning, as the principle of non-contradiction makes clear. Revelation renders this unity certain, showing that the God of creation is also the God of salvation history. It is the one and the same God who establishes and guarantees the intelligibility and reasonableness of the natural order of things, upon which scientists confidently depend, and who reveals Himself as the Father of our Lord Jesus Christ. Note the fact that this order, this natural order, is the order upon which scientists confidently depend. So it is object, same way of their study, of their investigations. Okay. Cosmological models and the debate on the possible role of a God creator. This is a very interesting ensemble of minds. Note that except Albert Einstein, all the others have papillon, no? It's a normal way of appearing in society for big scientists. Well, actually, we have an historian of science, Max von Laue, the last one. This is Max von Laue. He is an historian of science, but a peculiar historian of science because he was trained in science, and he used to accompany scientists in all the most important conferences around the world. So he wrote the history of science living together with scientists. Not a posteriori, decades after, but as a contemporary of many, many men and women research. This is the Hercules cluster. To appreciate how beautiful is this picture, we should turn the light off. Let me turn the light off only a few seconds. We have hundreds of galaxies, many hundreds of galaxies. It is about, if I remember well, about 500 million light years from the solar system. The whole radius of our universe is about 13.7 billion light years. Okay, cosmology tries to offer a mathematical representation of the physical universe. And the first who attempted to do this was Isaac Newton with the general law of gravitation, which has this form. And this other equation is the field equation formulated by Albert Einstein. The form is quite different, but the relevant parameters are there. For instance, look at this same constant appear here and appear here. And we have about 350 years between the two formulas. But the constant gravitation is there. And Isaac Newton discovered the measure of this constant. In this formula, we have mass and energy together. This is the reason why we have explicitly mass here, and we don't have explicitly mass here, because mass is here, is in this stress tensor. Okay. These are just to know what are these parameters about. We have the legenda of these parameters. But with this equation, we are able to give origin, to originate a family of many cosmological models. Because you just change a bit one of the parameters, and you have a family of cosmological models. Cosmological models of expanding universe, or cosmological models of steady-state universe. All of them stem from this formula. This is the formula of how the space-time reacts to the presence of mass energy. In the Newtonian view, we had an absolute space, an absolute time. In Einstein's view, we have a space-time geometry, which is the way in which space-time reacts to the existence of an entity which is mass and energy together. What is a cosmological model? There are a number of requirements, no? Cosmological model is a physical-mathematical differential equation. The previous Einstein's field equation is a differential equation. A physical-mathematical differential equation able to represent the distribution of matter energy within a space-time geometry. The structure in space and evolution in time of the physical universe. So we have the distribution of the whole of matter energy and how matter energy evolves in time and in space, including the origin at a certain level. We go more in depth, but a certain level, including the beginning, the origin, and announcing some future final scenarios of space-time and matter, if they are part of the model. Because there are models in which the initial singularity is not part of the model, and a final scenario is not part of the model. But for those models in which the beginning and the end is part of the model, the cosmological models, is able to do something on the beginning and on the end. The question on the origin of the universe in cosmology and the debate about the possible role of an intelligent creator. Just a number of quotes. We already know these quotes because I remember that we mentioned them in the first lecture. The debate arises in the context of the so-called problems of incompleteness. Remember? Ontological incompleteness last Wednesday. Logical or ontological. That is in the epistemological context of the problem of foundation. Actually, this debate is wrongly centered on the problem of a temporal beginning of time. So normally in popularization of science, the role of creator in the majority of cases is associated to the existence of a temporal beginning of time or not. Or, at times, it is associated to a specific choice of the boundary conditions of the equation describing the physical mathematical evolution in time of the cosmic models. Those of you who are familiar with differential equations, you know that every time you solve a differential, the integral and then a differential equation, you have a number of constants. You have a number of boundary conditions. These boundary conditions are not given by the system itself, but they have a specific value. So, who set the specific value of these constants? Question mark. So normally in popularization of science, the role of God creator is there. Is or in the beginning, time 0, or in the spatial set of parameters, which let the universe to be as it is, as it actually is. Also, to debate about the possible role of a creator stems from contemporary cosmology's desire to conceptualize the physical universe as a whole. Because if a physical cosmology of specific science would have as its own object to represent a part of reality, there is no reason to debate about the possible role of a creator. But if a specific science, natural sciences, has as its own object to give a comprehensive, all-embracing representation of the whole of reality, then the debate about the possible role of God arises. So these are basically the context in which this role arises. The reference to a creator is introduced in the context of the logic of the first move, endorsing the image of the God of the gap, of a God of the gap. This is actually the God of the gap. Who gives the value of the constants and who let according to the phrase of Stephen Hawking, who breathed within the equations? Who breathed fire within the equation to let the equation be? If the universe had a beginning, Stephen Hawking said, we might suppose that he had a creator. First context, t equals 0. But if the universe is completely self-contained with no boundary or no edge, it would have no beginning nor end. It would simply exist. But then, what room would there be for a creator? Many people don't like the idea that time had a beginning, probably because that notion smacks a bit of divine intervention. Stephen Hawking is also the author of this second statement. Many scientists are puzzled when it comes to the initial conditions of the universe, because they perceive that these borders on metaphysics and religion, the initial conditions, the boundary conditions, the basic constants of the differential equations. Now, have a bit of patience, and let's go a bit more in depth within these cosmological models. And let's resume these cosmological models in 3 great families, A, B, C. Family A is the family constituted by those cosmological models dominated by matter in an expanding universe, which predict or expect the existence of an initial gravitational singularity in the origin of space-time. And these family of models are called usually Big Bang models. We have standard models, Friedmann-Lemaitre solutions to Einstein field equations employing a Robertson-Walker geometry. But we have also cosmological models that remove or do not depend on the existence of an initial singularity. There is no beginning of time. These are the so-called steady state or quasi-stationary models. There is no expansion. Cyclic universe models. Models in which a geometric transformation that removes the dependence on time, thus generating a self-contained universe. Also, models that remove a singularity are those models describing the origin of matter energy as a quantum fluctuation from the nothingness, italics, of empty space. You have an empty space, nothingness, void. Universe is represented as a quantum fluctuation. There is no origin of time. There is a quantic fluctuation. Another family of models are those models employing the framework of a superstring theory and try to describe a pre-Big Bang era where classical space-time emerges from a timeless foam. So to emerge is not matter energy, but space-time. So it's not a quantum fluctuation, but it's just a foam. It's an undefined foam from which space-time emerges. The third family of models are multiverse models originating in inflation scenarios. Inflation scenarios are those scenarios in which we have an initial speed of expansion higher than the speed of light. It is possible because it is the whole space-time that expand at the velocity, at the speed higher than the speed of light. As you know, general relativity says that we cannot let an information go faster than the speed of light within the universe, but the whole of the universe can expand at the speed higher than the speed of light. And this kind of expansion is called inflation. There are a number of cosmological models with an initial inflation, and a consequence of this initial inflation is that we generate mathematically a number of independent, causally independent space-time regions, an ensemble of universes, one independent from the other. Let's have a look to the first family of models, Big Bang cosmological models with an initial space-time gravitational singularity. The gravitational singularity do not correspond to the physical mathematical definition of an origin of time, simply because the point t equals 0 does not belong to the domain of definition of the equations. The equation is not defined for t equals 0. And therefore, for t, which tends to 0, there is a divergence of the significant physical parameters, temperature, matter, and so on. I don't have a blackboard here, but imagine a very simple function, 1 over x. This function is something made this way. You have 0 here. This function goes to infinite as you approach to 0. But the point 0 does not belong to the domain of definition. So if you ask, what is the value of the function for x equals 0? The answer is, we don't know. Simply because the point t equals 0 does not belong to the function. Diverges. So in this kind of models, remember that t equals 0 do not belong, strictly speaking, to the domain in which the equations can be defined. They are not defined in that point. They diverge. So temperature go to infinite, for instance, no? Pressure go to infinite, and so on. This is a sketch of singularity and then expanding universe in time. Our cosmological model, starting from a Big Bang, belong to these 3 different subfamilies. The universe can end in a big crunch if the universe is, the space geometry is closed, then can continue to expand forever, but with an ever lower speed of expansion, or to expand forever accelerating. This is the inflation phase, no? Then the inflation stops, we have the normal expansion. Contemporary observational cosmology endorse this kind of curve. It seems that we are in a universe of this kind in which the expansion is accelerating due to a kind of energy that we call dark energy, simply because we do not know which kind of energy is. Of course, there are a minority of cosmologists that say there is no dark energy, there is no dark matter. We have to change completely our way of representing the universe. So we have to look for other field equations which are not Einstein's field equation. This is a minority stream, but it is present. And they say, we are in a moment similar to the change of frame between Ptolemaic and heliocentric cosmological system. No? We tried with the Ptolemaic system just to arrange everything because all the measures could turn out consistent with the observation, and we had the new parameters, new epicycles, everything. And then we realized that it is too much complicated. We had to change our mind. So they say we are in an epoch in which something similar appears. It is too much complicated. We have to introduce dark energy, dark matter. If we change, perhaps we don't need this kind of objects, no? And we have a new representation of the universe. But this time we don't know. We still don't know. To speak of the existence of this singularity as a theological event of creation makes no sense. Why? Because we do not possess a physics adequate for describing the conditions of matter energy and of space-time within the Planck era for sizes less than 10 to the minus 33 centimeters and times less than 10 to the minus 43 seconds. When we approach time equals 0, we enter within a representation of the space-time in which our equations fail. We have no longer equations to represent a so high energy, a so high pressure, a so dense universe. There is no possibility. We call this epoch Planck era. Also from a quantum worldview, we cannot enter within. It's a threshold. Since the mass density determining the space-time geometry also determines the rate at which time flows, approaching a finite single point could take an infinite time. We could have even models of universe in which the way in which you approach to t equals 0 lasts an infinite time. For instance, because if you have oscillation, and the range of oscillation is ever thinner, smaller as you approach, you have an infinite time needed to approach a point. So the origin of time does not coincide with the origin of nothing. From a theological viewpoint, the dependence of a created universe on a creator is not satisfactorily represented by a time beginning, simply because creation is not a single time event. Creation is much more than to begin in time. Have you thought that the very moment we are living now at 3.33, very special moment, we live now from the point of view of our dependence of God is absolutely of equal importance compared with the moment of the beginning of time, if there was any beginning of time. The beginning of time is no more important than the time we are living now. Our dependence of God is just the same. Of us, of matter, of universe as a whole. When gravitation and singularities are erroneously clothed with the theological overtones, then a fallacious association between Big Bang and creation inevitably arises. Next chapter will be theological in character. This chapter is scientific in character with a few theological references. Next chapter will be theological in character. So have patience, because I am just mentioning something theological, but the theological treatise is next chapter. Okay, these are universe model with a Big Bang initial singularity. We are in this kind of universe according to present observation. Green universe. Family B, steady-state cosmological models without any initial space-time singularity. They are models of universe without beginning or end, without any gravitational horizon, introduced by Einstein and de Sitter before the discovery of the expansion of the universe. Expansion of the universe was discovered by Edwin Hubble and Georges Lemaitre on 1929. These models were formulated before this date. After the discovery of the expansion of the universe, these models were maintained by introducing a local creation of mass, such as the cosmic density, homogeneity, and symmetry remain unchanged. That is, there are a number of models that say there is no expansion. We know that the universe expanded. Then we try to maintain the same parameter, density, temperature, everything, just adding a little input of matter. And this model have success in doing so. These models were used by some authors in the 1960s in an anti-theological sense, just to remove the initial space-time singularity erroneously considered to be too close to the theological idea of creation. I saw articles, entries of encyclopedias, in which some author said, we don't need any creator because our universe is well represented by a steady-state model, without any singularity. There are also, just for culture, for general scientific culture, there are also cycloidal and oscillating universe models. These models predicted the expansion of a new Big Bang after a corresponding Big Crunch, and so ad infinitum. They are cosmological models. They are consistent with the mathematics which sustain these models. They are possible only in a universe having a curvature parameters of this kind. Presently, the observation suggests a different curvature parameter. According to some authors, each cycle would not be perfectly symmetrical and reversible. Therefore, the number of cycles would be finite, not infinite, and the global entropy always increasing. Mathematicians, physicists have discovered that we cannot have an infinite number of cycles because each cycle, if our universe is of this kind, we don't know, but if our universe is a kind of a cyclical universe, each cycle has a radius a bit larger than the preceding cycle. We have a small loss of entropy, so each cycle is a bit more bigger than the preceding, and there will be a last cycle in which the universe is open. Does not close on itself no more. It does not no longer close on itself. From a purely mathematical point of view, an oscillating model exists also for this other kind of parameter. However, it would have one bounce only at t equals 0 for a radius ranging from minus infinite to plus infinite. These are the representation. This is the classical oscillating universe. These are expansion without a big crunch. This is the oscillating universe. Can begin this way or begin before. The radius of universe increases a bit to each cycle. We could have also this kind of representation, just a bounce here. Okay. You could ask, what is minus infinity of time? We don't know, but we have a question representing this. Have you solved in the high school second-degree equations? Do you remember that they had the two solutions, one negative and one positive? And the teacher said, we discard the negative solution because it has no sense, and we maintain the positive. Okay, this is the reason. We have solution, we have negative solution for time. They are there, no? Okay. Models that remove the initial space-time singularity by eliminating the geometrical dimension of time. These models were originally proposed by John Hartle and Stephen Hawking in 1974 by means of a geometric transformation and introducing an imaginary time, t, which tends to minus et, imaginary time, a space-time four-dimensional geometry admits the limit of a three-dimensional space geometry. The time fades, okay, is absorbed in a three-dimensional geometry. Once the t equals 0 initial singularity is removed, the cosmic model has no boundary condition. So we solve also the problem of why are there these boundary conditions? God set these conditions. No, there are no boundary conditions. It becomes a self-contained universe. In reality, this cosmological model does not start from nothing. It assumes the geometry of the superspace it uses, and all the maths you need to compute the probability of a three-dimensional geometry, that a three-dimensional geometry can emerge from a dimensionless point. None of these models start from metaphysical nothingness, nor these models without boundary condition. These are these models. With this transformation in time, you remove time equals 0. So the universe is self-contained. Cosmological models describe the origin of the universe as a quantum fluctuation. Let me end just this physical chapter, 3 or 4 minutes more, then we pass after break to the theological perspective. They were originally proposed by these guys. They become possible in a theoretical framework which unifies the four fundamental forces. Because in a theoretical framework in which the four fundamental forces, nuclear forces, strong nuclear forces, weak nuclear forces, electromagnetic force, and gravitational force are merged together in one only superforce, in this framework, you have quantized gravity. So if you move within a framework in which gravity is quantized, where you have quantum gravities, then the whole of the universe could be a quantum fluctuation. Because what fluctuates is not electromagnetic, electromagnetic energy, but quantum energy. It's the very quantum energy which fluctuates in a quantum framework. They operate under the assumption that the sum of gravitational energy, which is negative, and the mass energy, which is positive, present in the universe, is algebraically 0. And this is true. If this is true, we could have in principle a number of quantum gravity models, fluctuation from nothing, quantum nothing, which is not metaphysical nothing. Describing the appearance of the universe without any violation of the laws of conservation, they have been erroneously invoked to show the plausibility of a theological creation from nothing, or instead to argue that such a creation is unnecessary. You have no violation of conservation law, because the algebraic sum is 0. And I saw titles on scientific papers of authors who maintained the two opposite theses. One thesis is, finally, we have models of beginning of universe from quantum flotation, from nothing. Then we don't need any creator. We have no role for any creator. And I saw other titles. Finally, we have cosmological models which start from nothingness. So theological perspective of creation from nothingness is true. You know the ambiguity, no? Okay. Cosmological models of multiverse, many independent universes originated during the inflation cosmological epochs. These models were proposed by these authors. Sophisticated geometries describe the possibility of sequence of Big Bangs and their ramifications, subordinating child universes to mother universes. These models are invoked to find an explanation for the unusual anthropic condition given in our universe. We have an infinite ensemble of universe, then we know why our universe has exactly the parameters necessary for life, because it is just causally, by chance, is the only universe in which we can live, no? Because we have an ensembles and we live only in one possible universe. Models of many or even infinite universes, more or less consciously, recall the idea of a universe without beginning or end, the object of a continuous chaotic transformation. And these are artistic representation of this multiverse, of this many universe models. Each of these spheres, each of these sequences of sphere is a universe, an expanding universe. But we have a number of them. We live in this one, but there are many others, absolutely independent, without no possibility to exchange information, with autonomous independent space-time regions independent each from the other. Oh. Okay. Bubble universe. Each of these object, they look as fractals, our universe. Mother universe, baby universes. Okay. Then this is an artist's view of a multiple universes model emerging from inflation. Now, some philosophical and theological clarifications. And the first clarification is that the dependence of a created world on a creator is much more and other than solving the problem of the beginning of time. A universe without a beginning requires an ontological foundation and therefore an origin. Beginning and origin are two different concepts. Beginning is something which starts. Origin is a causal dependence from. My origin is my father and my mother. I began in time when? When you were able to count 4 cells or 8 cells or 2 cells in the womb of my mother. You have a certainty, but you Okay? If you want to set, beginning of time is there. But the origin of my life is much more. My origin is the free will of my mother and my father, right, to have a son. Okay. Resorting to an infinity of worlds, or to an infinite duration of time, does not escape the need to have a foundation for what is contingent. Matter, energy matter, is or contingent realities. To exist, they need some ontological foundation. Cosmological models predicted, or instead avoiding, a space-time gravitational singularity do not confirm nor contradict the theological concept of creation. Other clarifications. Cosmological models describing the appearance of the universe from quantum nothingness or from the void of space-time do not involve the concept of metaphysical nothingness. Every model must start from assuming some form of being. Geometric being, algebraic being, physical being, virtual being, laws, etc. Actually, none of these models presume to start from nothing. They presuppose the metrics and laws forming the basis of the space-time geometry. Or they presupposes the quantum representation the models use. These are forms of being something. As expected, all these models operate within a mathematical framework that bears no relationship with metaphysical nothingness. Metaphysical nothingness is no being, no laws, no formulations, no geometry, no space-time, no matter-energy, non-existence. And those scientists who reflect in a good way on these topics, they come to the same conclusions I am offering you now. Paul Davies, however successful our scientific explanation may be, they always have a certain starting assumption built in. For example, an explanation of some phenomenon in terms of physics presupposes the validity of the laws of physics, which are taken as given. But one can ask where these laws come from in the first place. Or could even question the origin of the logic upon which all scientific reasoning is founded. Sooner or later, we all have to accept something as given, whether it is God, or logic, or a set of laws, or some other foundation for existence. Clear? Another quote by Paul Davies. Although we may be able to find a cause for every event, and likely in view of quantum effects, still we would be left with the mystery of why the universe has the nature it does, or why there is any universe at all. This is the question. The universe is the way it is because God has chosen it to be that way. Science, which by definition deals only with the physical universe, might successfully explain one thing in terms of another. and that in terms of another, and so on. But the totality of physical things demands an explanation from without. Do you acknowledge, do you recognize here a problem of incompleteness? Both logical and ontological. Michael Heller, which is well known by one of you, actually, contemporary physical cosmology is not only the science of the whole universe, but also a science concerning those assumptions that permit the very possibility of a science of the universe. In choosing among these assumptions, cosmologists unconsciously resort to philosophical a priori pre-comprehensions and presupposition. The key word is this, unconsciously. In other terms, to do cosmology, as far as you understand cosmology as the science of the whole, if you want to do cosmology, you need philosophical presuppositions. You need philosophical assumptions. And you unconsciously do this kind of presuppositions and assumptions. But you do not explicit these kind of assumptions. And we go more in depth this point. So the science of the universe is the science of the physical evolution of space-time, of matter in space and time, and those philosophical framework you need unconsciously to do this. Because you are dealing with the problem of the wholeness. And the wholeness is a metaphysical concept. It's not an empirical concept. Have you thought about this? The wholeness is not an empirical concept, but a metaphysical concept. There is a question?
Yes. For example, when Lemaitre applies the equations of general relativity to the universe, what sort of philosophical presupposition is he doing?
The philosophical presupposition is that these laws of nature work, that there is a geometry, namely a Friedman-Lemaitre geometry. These are presuppositions. You need something to begin with. You need them. It is not a problem in itself. It could be a problem if you deny that you need this kind of presupposition, something given. And you could say, well, this sentence is ultimately the sentence of a philosopher of science, of a mathematician, but he is a priest. He is a type, but he is a priest. What if we ask the same to a couple of scientists, to cosmologists? And here are two textbooks of cosmology. This is the textbook I used in my university studies. McVitie, General Relativity and Cosmology. It is one of the textbook very well diffused, very well known in the 19th and also up to date. It is used in schools of cosmology. Have a look at the introduction of these two textbooks. McVitie's textbook was written in 1963. He writes, an individual scientist may perhaps believe that he pursues his work without considering philosophical questions. But this belief is illusory and arises simply because the scientist has unconsciously acquired some particular metaphysical outlook. Page 3 means that we are in the in the introduction, so in those considerations, those very general considerations that an author does at the beginning of a book. Okay. Introduction, 9. Roman number, typical of any introduction. Francesco Lucchin writes, subtle influences of personal philosophy, personal philosophical view, culture, and in some cases, religious background, lead to very different choices in paradigm in many branches of science. But this tendency is particularly noticeable in cosmology. So there are a number of presuppositions that there is a background, cultural, philosophical, even religious background. You have this background, so you propose your physical cosmology clothed with a number of assumptions you need to do cosmology, but they come from your spatial view of the universe, your personal view of the universe. Chapter 3, the notion of creation between philosophy of nature and theology. This chapter is more theological in character. Physical cosmology attempting to conceptualize the entire universe as unitary intelligible object. The universe constitutes a typically philosophical object because the whole cannot be the object of any possible experience. Could you have experience of the whole? Could we have experience of the whole? No. Nor of any direct empirical investigation. Speaking of the whole is always an ideal construction, which is starting from experience, moves towards a conceptual generalization. One universe, many universe, other in addition to a multi-universe model. They are philosophical speculations. They are not empirical measures. A cosmology that wants to be a science of the whole should necessarily include metaphysical, meta-empirical assumptions and a priori presuppositions. A physical definition of the universe, when possible, always remains philosophically incomplete. We have physical definition, physical cosmological definition of the universe, but they are philosophically incomplete. We need something more to complete these definitions. Let's have a look to a number of definitions. For instance, a metaphysical definition, a metaphysical notion of universe. The totality of existing entities insofar as they are referable to a single cause of their being. This is quite a general definition. The totality of existing entities, insofar as they are referable, are they linkable to a single cause of their being. But we have also a cosmological observational description. Observational cosmology. You have theoretical cosmology and observational cosmology. From an observational cosmological viewpoint, a definition of the universe could be everything what exists having a direct or indirect connection with observed physical and astronomical objects. This is a scientific definition of the universe. I have observations, I have a possibility of measures, also indirect measures, indirect effects, but founded on some kind of measurements. Note that the two definitions are different. This is much more general. This is extremely restricted, extremely definite. But you could have also a theoretical cosmological definition, which could, at a certain level, be independent from observations. The connected set of possible space-time events, which includes the present time and place, and the physical objects existing in all such events. I ask that they are connected events, but at times, or even I cannot measure them, but I know that they are connected in some way from a theoretical viewpoint. So they are the whole number of theoretical entities, but I could have no access to a direct or indirect observations of these objects. Now, the metaphysical and physical concepts of universe do not necessarily coincide. The universe is the same, the cosmos is the same, but the way in which I represent the universe from a metaphysical viewpoint or from a scientific viewpoint could not coincide each other. The first one, the metaphysical concept of universe, is independent of the variety of models which describe the material universe. A metaphysical notion of universe can be compatible with the different cosmological models. You could do by yourselves an exercise. Apply this definition to all the cosmological models we saw in the preceding hour. And this definition holds for all those models, no matter if they are emerging universes from a quantum fluctuation, no matter if they are universes with a beginning of time, without a beginning of time. They are all compatible with this philosophical notion. Science, that is the art of starting from something. Empirical analysis necessarily requires the existence, being, and specific properties, nature, essence, quidditas in Latin, of material entities. To be objects of empirical analysis, the object of physics must be something. The possibility of extracting energy from the geometry of space-time, vacuum energy, is not to create anything, but to deduce physical quantities from other quantities, geometric quantity, quantum field, so on. To create matter or energy by means of a quantum fluctuation of the physical vacuum is to deduce the existence of something, energy or matter, from the existence of something else, a system of laws, physical properties, even statistical laws which rule the probability to have a fluctuation. You have a law that tells you which is the probability that you have or not a fluctuation. But you have to start with this probability distribution in order to predict if you have or not a fluctuation. Cosmological analysis of the whole of the physical universe copes with the philosophical problem of ontological and logical incompleteness. The empirical sciences, cosmology in particular, come up against the very foundation of being and knowing. Remember the experience of ultimates we spoke about at the last lecture. Doing science, we have the experience of the foundations of the ultimate. We cope with the being and with the properties of being. Thomas Aquinas seems to have taken into account the philosophical questions raised by contemporary cosmology, because they are the same questions. Here are the surprising titles of some questiones he presents. From the commentary to Petrus Lombard's sentences. These are the titles of the questions, of the articles. Whether there is a first principle only. We have only one first principle of many first principles. One universe or many universes. Whether the act of creating can be made by agents other than God. Quantum fluctuations, space-time pre-Big Bang form. Whether the world is eternal, no dependence of time, as in Ortel-Hawking model. In the Summa Theologiae, which is a later work, as you know, a commentary to Pedro Lombardo's sentences was an earlier work of Thomas Aquinas. These are titles of questions and articles from the Summa Theologiae in the set of questions dedicated to the theology of creation. Whether primary matter is created by God or is an independent coordinate principle with Him. Whether the universe always existed. How God is said to have created heaven and earth in the beginning. The unity of the world, whether there is one world only. These articles were written 7-8 centuries ago. But why these titles look so similar to contemporary cosmology? Simply because they are philosophical questions. So the formulations changes. We have Newton, we have Galileo, we have Newton, we have Einstein, but the philosophical big questions remain exactly the same. I used to say to my students of theology that when they begin with a problem and they begin to study something specific, they have a question to solve. Before beginning their work, I suggest them to have a look to the summary, to the final index of Summa Theologiae by Thomas Aquinas. We have about 350 articles. And you have a good editions of Summa Theologiae in which you have in the final index all the titles. I did this by myself 30 years ago, and they are about 40 sheets, 40 pages of index. But I have all the articles one after the other. And I say, before beginning a work, look at these titles. And in the 90% of cases, the question where you are dealing with was already posed by Thomas Aquinas. So please have a look at his solution and then continue your work. So this stands also for contemporary scientists and cosmologists. Here are some key points of Aquinas' thought on creation. Creation should be understood first and foremost as a relationship. This is a very clear point of Thomas Aquinas' doctrine of creation. What is creation? First and foremost, a relation. It's not a moment. It's not a motion. It's not a change. It's a relation. Creation is not a motion or a change. Creation is a transcendent act outside time outside time. The effect of creation is in time, namely ourselves, these fabrics, these furnitures, ourselves are in time, but the act of creation is out of time. The relation is a transcendent relation. And the source of the relation is out of time, it's God Himself. Time cannot be the measure of creation. The beginning of the world cannot be deduced from within the world. This is sufficient to warn all mathematicians that they cannot work with a mathematical model trying to deduce if the world had a beginning or not. Because it is impossible from the world itself. The world depends ab eterno on a creator, and therefore a universe of infinite duration would also depend on God because He is the creator of time. So both a universe with the beginning of time and a universe without a beginning of time, they both depend on a creator. Creation and preservation in being are a single act of God the Creator. They are not two different acts. They are the same act of God the Creator. These are just quotes from Thomas Aquinas. Summa Theologiae, first part, question 46, article 3. It is said that the things were created at the beginning of time, not because the beginning of time is the measure of the creative act itself, but because the heavens and the earth were created together with time. Now creation is not a motion, not even the end of a motion. It is not the change from the passage from nothing to being is not a motion. It's not a movement. Because to be a movement, you need the 2 points, the point from which a movement begins and the point to which the movement ends, they both belong to the universe, exist. But the first point does not exist because it is nothingness. So even the passage from nothingness to being is not a motion. Creation places something in the thing created according to the relation only. Because what is created is not made by movement or by change. Hence, creation in the creature is only a certain relation to the Creator, as to the principle of its being. This is cosmology. This world is said to be one on account of its unity of order, according to which some things are ordered to others. For everything that comes from God is order in itself, and is ordered towards God. For this reason, all things concorporate in one world. Various worlds were admitted by those who did not establish an ordering wisdom as the cause of the world, but randomness. If we say that we have many independent worlds, they do not depend on a first cause only, we put the randomness as a first principle. This is a philosophical principle. For God to do one universe of an infinity of the universe is the same. There is no much effort to do many universes than one universe only. Conclusions. Cosmology, theology, and the human wandering on ultimate questions. The rationale of these conclusions is an attempt to foster the dialogue between natural science and theology, saying that it is important that theologians listen to what cosmologists say on this topic, understand what they say, and put in light their desire to know about the ultimate causes of the whole cosmos. So, on the part of theologians, it is a good work to put in light what are the real desires, what are the real aims of scientific cosmology. A bad way of behaving could be, I don't want to have anything to do with this kind of reasoning. This is your way to approach the cosmos. I have another way to approach the cosmos. No. And on the other hand, I also suggest that cosmologists and physicists could also listen to what many centuries ago philosophy and theology had already said on this topic. Contemporary cosmology has today the theoretical and in part the observational tools to conceptualize the physical universe as a single intelligible object. This is a matter of fact. Those equations I showed in one of the first slides are the demonstration that this is possible to do. This is a quite new situation, which allows cosmology to address ultimate philosophical questions, usually the object of philosophy of nature and of metaphysics, origin of the cosmos, purpose and meaning of cosmic evolution, and so on. In encountering these questions, cosmology perceives the problem of foundations and the problems of incompleteness, logical and ontological, recognizing the need for a meta-language and a metaphysics able to work with a broader level of abstraction. So the role of the philosopher and of the theologian is to help scientists to recognize that there is a meta-language they need, there is an implicit metaphysics they need to formulate, to have a complete description of the universe. Because starting from mathematics and physics only, you cannot offer a complete definition of the universe. These ultimate questions have no complete nor consistent answer within the scientific empirical method, but they are bound to arise because it is the scientist and no impersonal subject who is theoretical and existentially prompted to address them. This conclusion, that in my opinion is very, very clear, is not endorsed by many people. Because many people say, do not address this question starting from your work. These questions rise because they are personal subjects. And they cannot avoid these questions. The empirical method in itself has no possibility to formulate these questions in a complete way, in a convincing way, but the personal being who addresses these questions has to formulate them, because they are, at the end, the very questions that motivate their work. If these questions would not arise, there would be no scientists at all. Do you agree? Why you do science? Because you want to answer this kind of questions. Please.
world as a whole is impossible to resolve philosophically. And,
not philosophical, it is impossible to solve it scientifically. The whole is a philosophical concept.
See, but Immanuel Kant, I think, I don't remember exactly how the argument, which is his argument, but I think that maybe what Kant says, that because for Kant, nature is only our way of explaining nature.
I remember in the frame of the pure reason, the idea of the world is an antinomy.
Yes.
Okay.
So, according to what we have seen, may we say that Kant, what Kant says is not does not correspond to scientific world?
No, I would say that what Kant says, in my opinion, what Kant says in that context is what the scientific method says in the empirical context. Because we are in the frame of the pure reason, which is just the scientific method and what we need to let scientific method to work. Do you agree? More or less. There is room for more examples. So these ultimate questions have room in the theoretical work of scientists. Theologians should not see with suspicion the new conceptual frame displayed by physical cosmology. They should appreciate that ultimate questions are kept alive by science and help scientists to distinguish the different levels of abstraction they involved. Theologians should be content that these kind of ultimate questions survive, because no one today in our postmodern society address this kind of questions. So this is a good result. And have to help scientists to distinguish the different levels of abstraction they involve. At the same time, theologians should note and explain that the search for understanding and the search for ultimate meanings is driven by a personal subject whose insights and thoughts on reality necessarily and spontaneously transcend the empirical knowledge. There is a huge bibliography about the philosophical, the humanistic dimension of science, but this is a clear example of humanistic dimension of science. As a personal subject, these insights and these thoughts necessarily arise, but they transcend the empirical knowledge. Theologians, again, cannot limit themselves to providing epistemological clarification and pointing out misunderstandings. This is necessary, but it is not enough. You are speaking of nothingness, but it is not nothingness because metaphysically nothing is absolutely nothing. Okay, right. But please, go further. When discussing on theology and science, they must also make the most of the fact that these questions arise among men and women of science. This is the good results to highlight. It is inevitable that they arise, this question arise, because the physical universe is the effect of a personal world, which appeals and attracts, which is ultimately the very reason why we question this kind of things. Questions about the origin, the whole, the meaning, and the purpose of all, which cosmology raises, must be placed in dialogue with the reflection of the philosophy of nature and the realist metaphysics. In so doing, the scientific method becomes aware of its very foundations and protects itself from idealistic drifts. We have to avoid this kind of idealistic drifts. Okay. As an effect of this dialogue, scientists can realize that the being and the properties of the physical universe are given, and theologians unfold the face of the giver, the word logos. Actually, the very meaning of the word data, datum, is givenness. Theologians indicate as the Creator's loving decision to give. To do science, you need data. Data is plural from datum, which in Latin is the past participle of to give. Okay. Having this in mind, the epistemological experience of the foundational reality may become the religious experience of the encountering with the giver, acknowledging the world and the being as a personal gift, not the quantities of the constants of the physical laws, but the face of the giver. This is the difference. Such a view is consistent with scientific activity because the truly ultimate why the world is the way it is and not otherwise, cannot be derived through empirical investigations. We can receive it only as a gift, the very ultimate why of why the universe exists, or why I myself exist. This ultimate why has its only answer in the reason of a gift. Gratuitousness. From a general point of view, theologians should not look with suspicion that contemporary science, cosmology, physics, but even biology and anthropology is able, and they or all these sciences are able to trace back the steps of our cosmic and biological history, up to the questions about the origins. Theologians must not look with fear or with suspicion to this state of facts. Theologians instead can remind that such a long history and the chain of the many scientific causes lying therein have no access to the ultimate and to the most important question, namely, why am I, myself, here? Do you recognize the difference? The long chain of physical causes, and why I am here. I, and another person. In the dialogue between scientists and theologians, the point at stake is not to deny what science says, but to add what science is silent about. Okay, the lecture stops here, and here we have a general bibliography of a number of works about the topic I faced in this lecture. Okay, I will stop here for a few minutes to speak personally if you want, and let's see you on next Wednesday.